So we've talked about factoring quadratic trinomials. So remember, a quadratic trinomial is a trinomial of the form ax squared plus bx plus c. But we've specifically learned how to factor these where a is exactly 1. All right, so far that's all we know how to do. So we now need to look at these 4 special cases that could come up. So the 4 special cases that we'll address when we're talking about quadratic trinomials are what to do if you have a negative lead coefficient. So what if a isn't 1, but it's -1? How do we deal with that? What if a is something other than 1 or -1? How do we deal with that? We also have a situation where we can have a prime polynomial or a prime quadratic trinomial. This just means it's not going to factor over integers. So integers are those positive and negative whole numbers. It won't factor unless you threw in decimals or fractions. We don't want that. And then finally, we're going to look at a very specific setup for 2 variables, okay? So let's go ahead and get to it. So for example 3, it says factor each trinomial completely. So let's look at part A. Right off the bat, I see that the x squared term has a coefficient of -1. Okay, so what we want to do here is factor out a GCF of -1. Okay, we know how to factor a quadratic trinomial where x squared is exactly positive 1x squared. If it's got that negative, we don't know how to deal with that. But we do know how to factor out a GCF. And we also know that if the lead term is negative, we can factor out a negative GCF. And that's exactly what we're going to do here. We're going to say that we have a GCF of -1. So I'm going to rewrite this as 1 and then a set of parentheses. What's going to go inside those parentheses is the quotient after I divide all of my terms by -1. So let's divide. And you'll see that we really just have sign changes. So negative x squared divided by -1 is positive x squared. 13x divided by -1 is negative 13x. And negative 40 divided by -1 is positive 40. So now our goal is to see if this stuff in parentheses can be factored because it's now a quadratic trinomial where a is exactly 1. The issue here is this -1 that you factored out, you can't forget about it. It has to be in your final answer. So the final format that we're going to see is going to be a -1. However, we don't generally write the 1, we just write the negative. And then we're going to have the product of 2 binomials. Okay, so looking inside the parentheses, we need to find factors of 40 that add to be -13. So if the constant is positive, the factors that we're looking for have to have the same sign, both positive or both negative. And because they need to add up to be -13, we know the 2 factors have to be negative. There's no way that you can add 2 positive factors and get a negative sum, okay? So I'm going to go ahead and show you all of the factors, and then I'll kind of point out why we know that those positive factors can be tossed out. Okay, so we could try for factors of 40 and 1 or -40 and -1. We could try for 20 and 2 or -20 and -2. 3 does not go into 40, but 4 does. So we could try for 10 and 4 or -10 and -4. We could also try for 5 definitely goes in. So 8 and 5 or -8 and -5. If you are struggling with where I'm getting these factors, pause the video, grab a calculator, take your constant 40, divide it by 1, 2, 3, 4, 5, 6, 7, 8. Once you see your factors start to repeat, you know you're done. That's the first thing. And then the second thing is anytime you get decimals, toss it out. You can't consider it because that's not an integer. So you're only looking for when you get integer factors, okay? Now, when we add these, 40 and 1 is 41, 20 and 2 is 22, 10 and 4 is 14, 8 and 5 is 13. So again, we have these 2 positive factors. When we add them, we're always going to get a positive sum. So you can just completely ignore those 2 positive factors because we know that we need to get negative factors in order to get this negative sum of 13. Okay. Now on the other side, we have 40 and or -40 and -1, -20 and -2, -10 and -4, and then that's 14 actually. And then -8 and -5, there's my magical -13. So that's the pair of factors that I want to use. Okay. So my final answer is going to be that negative that we initially factored out, and then x minus 8, x minus 5. You could certainly also rewrite this as negative and then parentheses x minus 5 times x minus 8. It doesn't matter which binomial you put in which factor, just make sure the sign on the factor is correct. So there we have our final answer. Now, let's say you wanted to check this. So we have negative x minus 8 times x minus 5. I'm going to start by foiling, and then I'm just never going to forget that I have that negative out there. So x times x is x squared. X times negative 5 is negative 5x. Negative 8 times x is negative 8x. Negative 8 times negative 5 is positive 40. Well, that simplifies to negative 1. In parentheses or brackets, we still have x squared minus 13x plus 40. But our goal is to get what we started with right here. So now we distribute the negative 1 at the end, and we get negative x squared plus 13x plus 40. And if you look carefully, that is exactly what we started with here. So we know our factoring is good. We were able to check it. Just know that this is the final answer you're looking for. What has that green star beside it? All right, let's look at part B. Right off the bat, I noticed two things. I noticed one, this is not a degree 2 polynomial, it's a degree 3 polynomial. We know how to factor quadratic trinomials. That means the degree is 2, okay? We also have a coefficient on the lead term that is not 1, okay? So in this case, we would just sort of be like, well, we can't factor this. It's not quadratic and it doesn't have a coefficient of 1 on the lead term. However, if you can find a GCF that when factored out gives you a quadratic trinomial where a is 1, that's an awesome thing to do. So let's see if we have a GCF. So looking at the coefficients first, the smallest coefficient is 3. It is a factor of 15. It is also a factor of 18. So right now I can say that we definitely have a GCF of at least 3, okay? Now we want to look at the variables. Do all of the terms have a variable? Yes. What's the smallest exponent on the variable? 1. So we can say that we have an x that's common to all 3 terms. So now we have a GCF of 3x. Ideally, when we factor this GCF of 3x out, we'll be left with a quadratic trinomial where a is 1. Okay? So let's get started. So I've got my GCF times, and I've made myself a little set of parentheses where I can put the quotient I get after dividing out the GCF. I'm going to divide each term by 3x. Hopefully you're getting a little bit better at some of these simple steps like this. Okay, so I want to start going through them a little bit quicker. So in the first term, 3 divided by 3 is 1. Okay, and then x to the third divided by x, that's just a quotient rule. I keep the base. I subtract my exponents. 3 minus 1 is 2. Okay, middle term, negative 15 divided by 3 is negative 5. And then again, I've got a quotient rule, so I keep my base of x, subtract my exponents. 2 minus 1 is 1, so I just get negative 5x. Finally, 18 divided by 3 is 6. And then we do this thing in math. I've mentioned this 5 dozen times, it feels like. We say things cancel. We could be like, oh, these x's here, they cancel. Yeah, they do, because they have a quotient of 1. So x divided by x is 1. 1 times 6 is 6. There we have it. We now want to see if we can factor this stuff inside parentheses. If it is factorable, our final answer will be 3x. Never forget the GCF. It's always a part of the final answer. But we're going to get the GCF of 3x times 2 sets of parentheses. So let's see if we can factor the stuff inside the parentheses right here. So I'm looking for factors of 6. And since 6 is positive, the two factors have to both be positive or both be negative, okay? So I could try 6 and 1 or 3 and 2. I could also try negative 6, negative 1, negative 3, negative 2. Now, the factors that we choose have to have a sum of negative 5. There is no way to add 2 positives and get a negative sum, so we can just ignore those completely. They're not even going to be considered. Now, looking at the other factors, we have negative 6 and negative 1. They have a sum of negative 7. Negative 3 and negative 2 have a sum of negative 5. So that's our magic pair. That is the pair of factors that multiply to give us positive 6, but simultaneously add to give us negative 5. So I would fill in x minus 3, x minus 2. Instead, I could have done x minus 2 and then x minus 3. It's fine. It doesn't matter which set of parentheses you put, which factor. Just make sure the sign in front of the factor is correct. So our final answer has to include that initial GCF that we factored out. Okay? Let's go ahead and look at parts C and D, and then that'll be it for this worksheet. So for part C, we have x squared minus 16x plus 12. This is a quadratic trinomial. It has a coefficient of 1 on the square term. Let's get to it. So we're looking for factors of 12. both positive or both negative factors that have a sum of -16, okay? So we could do 12 and 1, 6 and 2, 3 and 4. However, all three of these pairs of factors are going to have a positive sum, but we need a negative sum. So we can just ignore those. Those aren't even going to work, okay? There's no way to multiply two positive factors, or there's no way to add two positive factors and get a negative sum. It just won't work. So let's look at their negative counterparts. Well, -12 and -1 have a sum of -13. -6 and -2 have a sum of -8. -3, -4 have a sum of -7. But all of this is problematic because we need a sum of -16. So there are no factors with a sum of -16. So what does that mean? Well, if there are no factors of the constant that add to be the coefficient of x, we have to say that that quadratic trinomial is prime. Okay. Last up, we have part D, and you can see right off we have two different variables, but notice the format. We have a times the first variable squared plus b times a single x and then a single y plus c times the second variable squared. In order for this factoring to work, it has to be in this format, okay? So there's going to be an x squared term, an xy term, and a y squared term, okay? So when this factors, it's still going to factor as two binomials. We're still going to start each binomial with an x. That'll give us that x squared term. But how on earth do we get the xy and the y squared? Well, it's really quite simple. We end each binomial with a y. Okay, the rest of the factoring is exactly the same. We want to find factors of -30 that have a sum of -1. Now, because the constant, or not the constant, but because the coefficient of y squared is negative, our factors have to have different signs, one positive, one negative, okay? So we're looking at 30 and -1, or -30 and +1. We could look at 15 and -2, or -15 and +2. We could look at 10 and -3, -10 and +3. We could also look at, let's see, 5 and 6. So we could look at 6 and -5, or -6 and +5. Now, there is a hint to which set of factors we should look at. Because the middle coefficient is negative, that tells me the larger of the two factors needs to be negative. So I could basically ignore the first row, or the first column rather, of factors, but let's go ahead and just add them all up so you can see. So I'm going to do all of the sums in red. So we would get 29, 13, 7, 1, -29, -13, -7, and -1. Now, we need our middle coefficient to be -1. So which of these pairs has a sum of -1? This pair right here. Watch your signs, okay? So now I just want to fill in a -6 and a 5. And that's it. Well, let me rewrite that so it's a little easier to read. And there's your final answer. Okay, so those are the four special cases. You'll definitely see the GCF ones quite a bit. The two variable one, you don't see that very often, but I wanted to show you just in case. The prime one, you will have prime quadratic trinomials. They're not super, super common, but they definitely show up. Okay, so A, B, and C are probably the most common, with A and B showing up the absolute most. Okay, so make sure you get some time studying how to factor quadratic trinomials where A is 1, because in the next worksheet, we're going to look at factoring quadratic trinomials where A is not 1. All right.